HSO4 minus bisulfate ion plus water gives you sulfate plus H3O plus. Assuming constant temperature, what would happen if I add potassium sulfate? What do we know about potassium sulfate in water? It gives you potassium ions and sulfate ions. So if I have more sulfate ions, look at my Q right here. Sulfate times hydronium over HSO4 minus, and that's just water. That's activities 1, right? So what would happen if I have more of this? Q gets bigger. So temporarily, as a result of the stress, we say, or momentarily as a result of the stress, Q has gotten bigger than KEQ. So which way will the equilibrium shift? Which direction will the reaction take in order to counteract that effect? Okay, it shifts to the left, right? Because here's a simple way of thinking about it. If you're putting more sulfate in, the system will try to counteract what you did. If you put more sulfate in, it will try to get rid of some of it, so it will shift to the left. Okay, add more products, shift to the left. Now, why did I specifically mention solid here? The reason is that if you add, let's say, potassium sulfate that's already in solution, then if you're adding more sulfate, you might be adding more sulfate, but you'll also be changing the volume, so that can be complicated here because you're changing all the concentrations when you change the total volume. Okay, so you have to be careful when you do this thing. So, like if I said just add a very dilute solution of potassium sulfate, then it's not going to be, the impact's not going to be as much as if you did solid potassium sulfate. In fact, it could be the other way, because if you add more water, what happens? Okay, if this concentration drops, if that concentration drops, that concentration drops, the total Q could actually drop. Okay, like if you double all the volumes, this will be cut in half, that will be cut in half, and that will be cut in half. The whole Q will become half of what it was, so it will actually shift to the right. Okay, so the net stress that you've done is adding water if you're adding a dilute solution of potassium sulfate. Let's look at the same equilibrium reaction. What if you add sodium bisulfate solid? This is going to be a source of what? What does this do in water? It dissociates and gives you sodium ions and bisulfate ions. So will the reaction shift to the left or to the right? If you add more reactants, you're making Q smaller. If Q is smaller, which direction will it take? It goes to the right to make it big again, okay? So correct answer is shifts to the right. What happens if I add barium chloride solid? What does barium chloride do in water? It gives you barium ions and chloride ions. Oops. Okay. Are we adding any reactant, removing any reactant? Okay, this is where your earlier class is going to haunt you, because now you have to remember your solubility rules. Barium and sulfate will precipitate. So what does barium do? It actually removes sulfate ions. It forms barium sulfate solid. So which way will the reaction shift? To the left or to the right? Will shift to the right. You're removing sulfate, so what happens to this number right here? This drops, right? So Q drops. If Q drops, then the reaction shifts to the right. Okay? Let's look at this. What happens if you add more water? Actually, I covered this earlier. So let's say you add water. Let's imagine you add enough water so you double the volume. Okay? Will it shift to the left or to the right? Okay. Let's just imagine a situation where you add so much water so you double it. So this is now half of what it was. This is now half of what it was momentarily anyway. And this is now half of what it was. What happens to Q now? It's going to be half of what it was, right? Because times this 1/2 and that 1/2 will cancel out. You have an extra 1/2 factor in the numerator. So now system will now respond by trying to increase Q, so the reaction shifts to the right. Okay. Here's a way of looking at it in terms of the system counteracting what you're trying to do. What is it you're trying to do when you add more water? You're just making the solution more dilute, right? More water makes the solution more dilute. So what the system tries to do is to counteract that, is to make more solutes. So here you have 1 mole of solute on the left being replaced by 2 moles of solute. So that's the opposite effect. So the effect of the immediate effect of putting more water is to lower the concentration of everything, right? So the counteracting effect, according to Le Chatelier's principle, would be to produce more solid particles, and it shifts to the direction of having more solid particles.